Hi everyone. So in the previous few videos we've been factoring, right? And we've had different methods of factoring. And at this point it might all seem a little bit confusing. So in this video I hope to sort of put it all together so that given a factoring problem, you should be able to just go through this procedure and be able to factor anything that we throw at you, right? So the first thing you should always do when factoring is find the GCF. That's the greatest common factor. Greatest common factor. Right, so that was the first thing we did in this chapter, right? And so there's two possibilities. The first is that the GCF is 1, and if that's the case, then go on to step 2. So if the GCF is not 1, CF, then factor it out. Factor out the GCF. Okay. Now, there's some problems where if you don't do this, it'll be okay, and you can do it later. There are other problems, though, where if you don't factor out the GCF first, you're just going to get stuck right there, and you won't be able to do anything else. So it's always a good idea to do it first. In some cases, you have to. Right? All right. So after you factor out the GCF, if it's not 1, what do you do next? Right. Now you just count the number of terms. Right. How many things are we adding or subtracting? Right. And, well, it's either going to be 2, 3, or 4. I suppose in some problems it could be 5. I don't think we've seen any, so I don't think those are going to come up. So 2, 3, or 4, right? So let's start with 4 terms. If you have 4 terms, then it's pretty simple. You factor by grouping. Remember what that involved? Splitting it up into 2 and 2, right? The first 2 terms and the last 2 terms, and then you factor those separately, right? If there are 3 terms, then this gets to be a little tricky because you have a choice, right? There's 3 different methods that you can use to factor a trinomial, right? So 3 terms means it's a trinomial. So the method that always works is called the AC method. Right? And we did a lot of examples with the AC method, right? Right. But then there's 2 other possibilities. And these are shortcuts that sometimes work and sometimes don't, right? So one shortcut is if A is 1, right, then you just look for the 2 numbers that multiply to C and add to B, right? Then find 2 numbers, whose product is C and whose sum is B. So you do the usual thing. And third, the last method for trinomials are the perfect square trinomials. And again, this doesn't always work. They have to be in the very specific form. And those forms are, I'll write it here, a squared plus 2ab plus b squared is equal to a plus b squared. That's how you factor that. And if it's a squared minus 2ab plus b squared, that factors as a minus b squared. Okay, so again, when you have exactly this form here, or this form here, then the factoring is done for you, right? You just turn it into this. But if it's not of this form, then you can't do it that way. Then you just have to go back and use the AC method, right? Okay. So yeah, the trinomials are probably the most difficult simply because you have three options here. Of course, you can always just use the AC method, right? That might be a lot more difficult if it is a perfect square trinomial, but at least it will work eventually, right? And then finally, if there's only two terms, then it's got to be one of these four possibilities, actually. One is it's the difference of two perfect squares, a squared minus b squared, and that factors as a minus b times a plus b. It could be the sum of two squares, a squared plus b squared. If that's the case, you're in luck, because that's going to be prime, right? Or not factorable. At least as far as we're concerned. Okay. And then there's two other possibilities. There's the difference of cubes. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. Right? And be careful you don't put a 2 in there, right? This is not a perfect square trinomial. And finally, a cubed plus b cubed. Be careful, that's not prime. That can be factored as a plus b times a squared minus ab plus b squared. Right. So those are the only four possibilities for binomials. Right. Again, assuming that you've factored out the GCF first, then it reduces to one of these four. Okay, and that's it. Right. So that's all there is to factoring. So let's get some more practice and do a few more of these problems, and hopefully it'll be, after this it should be pretty clear how to factor. Okay, first problem. Factor completely 4y cubed minus 64y squared. Okay, so remember, first thing you always look for, your first step is always GCF. What is the GCF here? So we have a 4y cubed, and we have a 64y squared. Right, so 4 is just 2 times 2. It's 2 squared. And then we have y cubed, right? 64 is going to be, well, 2 times 2 times 2 times 2 times 2 times 2. 2 to the 6 times y squared. So remember how to find the GCF. You use the smallest exponent. So for the 2, we have a choice between a 6 and a 2. What's smaller, 6 or 2? Obviously 2, right? And then for the y's, we have a choice, for the exponent, we have a choice between a 3 and a 2. Well, 2 is smaller than 3, so we'll use the 2. So 2 squared times y squared, which is just 4 times y squared. So that's the GCF. Okay, so that's what we're factoring out here, 4y squared. Right, so now you just divide, right? 4 divided by 4 is 1. We don't need to write 1 though, right? And y cubed divided by y squared is just y. Minus, right, because that's a minus. 64 divided by 4 is 16. And y squared divided by y squared is, well, y to the 0, or just 1. Right. So that's it. So we have 4y squared times y minus 16. Right. Now, y minus 16 is a binomial, and 16 is a perfect square, right? 16 is 4 squared. However, it's not y squared. It's not a squared minus b squared, right? There's no 2 here. So you can think of it as a minus b squared, but unless they're both perfect squares, you won't be able to do anything with this, right? So the y minus 16 is prime. So that's how we know we're done. We can stop right there. Okay, so that's our first example. Let's do another one. Okay, next example. Factor completely 6x cubed minus 5x squared minus 18x plus 15. Okay, so first step, as always, what's the GCF? Right, so we have 6x cubed, 5x squared, 18x, and 15. And I know some are plus, some are minus. The minus sign doesn't really matter, right? The first term is not negative, so we're not factoring out a negative. All right, so notice there's no x in the last term here, so x is not a common factor. So it's really just the numbers. Right, 6 is 2 times 3. Right? 5 is, well, just 1 times 5. And 18 is 2 times 9, and 2 times 9. 9 is 3 squared. And then 15 is just 3 times 5. Right? So the GCF is 1. Right? All 4 of these have nothing in common other than the 1. Right? And I'll have that invisible 1 there. Right? There's no 2. That's a factor of 5, right? And it's not a factor of 15 either, right? 3 is not a factor of 5, right? And 5 is not a factor of 6. So yeah, all 4 of these only have the 1 in common. So GCF is 1. That means we go on to the next step. The next step is how many terms? Well, there's 4 terms. So that tells me we have to factor by grouping. So remember how that works. I'll write it down again. 6x cubed minus 5x squared, and then minus 18x plus 15. So grouping just means split it up, do the first 2 terms and the last 2 terms separately. So what's the GCF in just the first 2 terms? 6 and 5 have nothing in common, right, other than 1. But they both have an x. In fact, they have 2 x's, right? X squared is the GCF. So we'll factor out the x squared. Oops. Yep. Factor out x squared, leaving you with 6x minus 5. Okay, so that's the first 2. Now we go to these 2 over here. The negative 18x plus 15. Oops, plus 15. So 18 and 15, well, if you look here on the left, they both have a 3 in common, right? So 3 is the GCF for 15 and 18. So we'll factor out a 3. However, the first term is negative, so we'll factor out a negative 3. So negative 18x divided by negative 3 is positive 6x. 15 divided by negative 3 is negative 5. Okay. So this is going to work because the 6x minus 5 is now our common factor. Even though it's a binomial, it's 2 terms, it is a common factor for both of these terms. So we'll factor out the 6x minus 5 and multiply by x squared, right? And this negative 3 here. Okay, or at least okay so far, right? Right. So now just ask yourself, is there anything else we can do here? Is the 6x minus 5, that's a binomial, but it's not the difference of squares, right? It's not the difference of cubes. The GCF is 1. So there's nothing we can do with the 6x minus 5. What about the x squared minus 3? Well, it's a binomial, right? And it is the difference, but it's not the difference of two squares. In particular, 3 is not a perfect square. Right? Even though the x squared is, you can say a is x, right? But 3 is not a perfect square, and so that's how we know we're done. This is as far as we can go. It's factored completely. Okay. Right. Let's do another one. Okay, next one. 5x squared minus 8x minus 4. Factor this completely. Okay, so first step, GCF. Well, I hope it's clear that it's going to be 1 here, right? Because the leading coefficient here, the a, if you will, a is 5. So let's write that down. A is 5, b is negative 8, and c is negative 4. So there's no 5s that are factors of 8 or 4, right? Remember, 4 is just 2 times 2. 8 is 2 times 2 times 2. But there's no 2s in 5, right? 2 is not a factor of 5. Right? And there's no x at the end, so x is not a common factor either. So the GCF is 1. Okay. Step 2 is number of terms. There are 3 terms, so this is one of those dreaded trinomials. Right. And a is not 1, so we don't have that shortcut available. And 5 is not a perfect square, so we know this is not a perfect square trinomial. Right? And even though 4 is a perfect square, this minus sign here would have to be a plus. Okay. So it looks like we have to use the AC method here. So remember how that works. We multiply a times c, which in this case is 5 times negative 4, or negative 20. Okay, so step 2, we look for 2 numbers, right, that multiply to negative 20. So the product is negative 20, and the sum has to be b. b is negative 8. Okay, so let's see, what 2 numbers multiply to negative 20? Well, 1 times negative 20. But 1 minus 20 is negative 19, which is not negative 8. How about 2 times negative 10? That's also negative 20. And 2 minus 10 is negative 8. And there's our match, right? So our next step, right, step 3 here for the AC method. We have 5x squared minus 8x minus 4. And we split up the middle term, the minus 8x, as, well, 2x minus 10x, right? Because that's also just negative 8x. So we still have 5x squared plus 2x minus 10x minus 4. And finally, step 4, well, now that we have 4 terms, we factor by grouping. Right. And we did that in the last problem. So here we split this up. From the first 2 terms, all we can factor out, yet again, is just an x. And that leaves us with 5x, oops, sorry about that, 5x plus 2. And from the last 2 terms, we can factor out a negative 2. Right? So negative 10x divided by negative 2 is 5x. Negative 4 divided by negative 2 is positive 2. So now we factor out the 5x plus 2. 5x plus 2 is our common factor, and it multiplies x minus 2, right? And now just check. This is prime. This is prime. There's nothing else we can do here, right? We are now done. And so there's our answer for 5x squared minus 8x minus 4. It factors as 5x plus 2 times x minus 2. Of course, I've mentioned many times already that if your answer is x minus 2 times 5x plus 2, you did nothing wrong. It's just as good, right? All you're doing is switching the order. And as long as you're multiplying, switching the order doesn't matter. Okay, let's keep going. Let's do a few more. Okay, so we have 8m cubed minus 4m squared minus 12m. Okay. So, as always, let's look for the GCF. All right. Yes, it's been 1 in the last two examples, but I don't think it's 1 here. 8, 4, and 12 are all divisible by 4. Right? And they each contain an m, a factor of m. So it looks like the GCF is just 4m. Right? Oops. Sorry, 4m. So let's factor that out. Factor out the 4m, and when we divide 8m cubed by 4m, we get 2m squared. Negative 4m squared divided by 4m is just negative m, and negative 12 divided by 4 is negative 3. Okay. So there we go, right? We factored out the 4m. Now, is there anything else we can do? Is this thing here, the trinomial 2m squared minus m minus 3, is that prime, or can we factor that any further? So, right, so that's probably not clear. At least not to me it isn't, right? So let's look at the 2m squared minus m minus 3 separately, right? Suppose that were the problem. How would you factor that? So it's a trinomial, right? The GCF at this point is 1. In fact, if the GCF is not 1, it means we didn't factor the original GCF correctly. We found the wrong GCF there. So at this point, right, the GCF should be 1. So now all that's left, because it's a trinomial, is the AC method here. All right, A is not 1. Right, A is 2, well, let's write that down. A is 2, B is negative 1, and C is negative 3. So it's not a perfect square trinomial, and A is not 1. So yet again, it's the AC method. So let's see, A times C is 2 times negative 3 is negative 6. So what two numbers have a product of negative 6 and a sum of negative 1? Okay, so I hope you don't struggle with this because it's right here, 2 and negative 3. Well, okay, let's write down all the possibilities here, even though that should be it. Because you might start with 6 times negative 1, right? That's negative 6. But 6 minus 1 is 5, which is not negative 1. And in fact, it's not negative. So that tells me you should switch, make it negative 6 times positive 1. Negative 6 plus 1 is negative 5, but we're looking for negative 1, right? So that's not it either. So I think the only other option here is negative 3 times 2, because negative 3 plus 2 is negative 1. And that's our match. That's the sum, right? Okay, so we're going to take the 2m squared minus 1m minus 3 and split up the negative 1m as negative 3m plus 2m, right? And now we have 4 terms. So, as usual, factor by grouping. From the first 2 terms, we can factor out an m. leaving you with 2m minus 3. And in the last two terms, this 2m minus 3, well, the GCF is 1. So I think all we can factor out is a 1. Right. And I think that's all we need to do. The 2m minus 3 is our common factor. Oops, should have had equal signs here. So let's factor out the 2m minus 3. And that multiplies the m plus 1. Okay, so that's it, right? 2m squared minus m minus 3 factors as 2m minus 3 times m plus 1. Now, for the original problem, don't forget we also had the 4m as the GCF. So now, this factors as 4m times 2m minus 3 times m plus 1. And now we're done. Right? You can verify that the 2m minus 3 and the m plus 1, these are prime. You can't go any further with those. All right. Yeah, so this was 2 steps, right? GCF, factor that out first, and then you have to make sure that this is not prime here, that you can factor that further. Right? So we've talked about this. What if you leave it like this? What if this was your answer? Well, that's not the answer, right? That's not factored completely. It is factored, however, so you will get partial credit for this answer here. But you are going to lose points because you did not factor the 2m squared minus m minus 3. It is factorable by the AC method, as we did down here. Right? All of this. Okay, so yeah, be careful of that and make sure that you factor completely. Because in some problems, it's more than just one step. Right? I think up until now, it was all just one step here, right? Okay. Yeah, let's keep going. Okay, next one, factor completely 6p squared minus 7p plus 3. So this is another 3 terms, right? It's a trinomial. First step, GCF. Well, 6 and 3 have a common factor of 3, but 3 is not a factor of 7, or negative 7, for that matter. So GCF is 1. Okay. Now what? Well, we know there's 3 terms. It's a trinomial. But 6 and 3 are not perfect squares, right? And 6 is not 1. So this is the AC method again. Right? It does come up a lot, so make sure you know the AC method. All right, so step 1 of the AC method is to multiply A times C. So let's write down what A is. A is 6. Oops. B is negative 7, and C is 3. So A times C is 6 times 3, which is 18. Okay, so we're looking for 2 numbers whose product is 18, so they multiply to 18. And the sum, when you add them, you should get B, which is negative 7. So let's see, how do we find those? So let's start with the obvious. 1 times 18 is 18, but 1 plus 18 is 19, which is not negative 7, so that's not a match. And worse, it's not even the same sign. It should be a negative, not a positive. Okay, so that tells me that both numbers should be negative. Now when you add them, negative 1 plus negative 18, you get negative 19, which is still wrong. It's not negative 7, but now at least they're both negative. Got it? Okay, so now we want both negative numbers. So now if we divide by negative 2, we get negative 9. So negative 2 plus negative 9 is negative 11, which is still not negative 7. No match. Okay, so divide by negative 3, and you get negative 6. Negative 3 minus 6 is negative 9. Still no match. It's not negative 7. So let's keep going. Can we divide by negative 4? No, not evenly. We get negative 9 over 2, right? We don't want fractions. Can we divide by negative 5? Nope, same thing. You get negative 18 over 5. We don't want fractions. Can we divide by negative 6? Yes, and we get negative 3. So negative 6 minus 3 is negative 9. But wait a minute, we did that already, right? All we did was change the order here. So we're going backwards now, right? So that means we're done. If you keep going, right, it's not going to be negative 7, not going to be negative 8. You'll get negative 9 and negative 2, but we did negative 2 and negative 9 already. So changing the order here doesn't affect your sum. It's still negative 11, which is not negative 7. Okay, so no matter what combination we choose here, we're never going to end up with negative 7 as our sum. Just not going to happen, right? So that's it. There's no way to do this, right? This is not factorable. Right? Or we use the word prime to describe a polynomial that cannot be factored. So this is an example where the polynomial, the trinomial here is prime. Okay? Now, the only way to know that is to go through this list and go through all combinations, well, at least all of them until you get to your repeat. Right? So as it turns out, we only had to go through these 4 here. Because at this stage, this one here is the same as this one. So once you exhaust all the possibilities, all the combinations of two numbers that multiply to 18, if none of them add to negative 7, then your conclusion is that it's prime. Got it? So yep, you got to show your work. You got to show all these to establish that it's prime. Okay? All right, next one. All right, our next one is 2y squared minus 28y plus 98. Okay, so first step is GCF. In this case, they're all even numbers, so they're all divisible by 2. Obviously, we can't go any higher than 2, since the first number, the a, is the 2, right? So let's factor out the 2. We'll get y squared minus 14y plus 49. Okay? So is that it? Can we go any further than that? So let's look at the y squared minus 14y plus 49. It's another trinomial, but in this case a is 1, so we have that shortcut. Also 49 is a perfect square, right? And 1 is a perfect square. So let's look for perfect square trinomial. Right, so we have 1y squared minus 14y plus 49 is 7 times 7, 7 squared, right? So what is 2ab here? Sorry, 2ab is 2 times y times 7, which is 14y. Of course, it should be negative 14y, but that's fine. So this just factors as, right, a minus b squared, where a is just y and b is 7. So y minus 7 squared. Okay, so again, when it's a nice perfect square trinomial, it's pretty quick. If that was too quick or you didn't get it, I'm going to do it again. I'll do it over here. Just by the usual, well, you can use the AC method, of course. But in this case, since a is 1, it's just y times y is 1. So what two numbers multiply to 49 and add to negative 14? Well, 49 is negative 1 times negative 49, but that adds to negative 50. So it turns out you're not going to be able to divide by negative 2, or negative 3, or negative 4, or negative 5, or negative 6. But negative 7 works. It's negative 7 times negative 7. And negative 7 plus negative 7 is negative 14, and there's our match. So it's y minus 7 times y minus 7. But remember, don't leave it like that. If it's the same factor, it just means it's squared. So y minus 7 squared. Right. Same answer we got by using perfect squares. And if you had to use the AC method, that works too. So this trinomial, y squared minus 14y plus 49, factors as y minus 7, the quantity squared. And now we know we're done, right? Because the y minus 7 is itself is prime. Okay, so that's it. Again, 2 steps, GCF, and then the trinomial, which over here on the left, we used a perfect square trinomial. And on the right, we just use the a equals 1 simple method for factoring trinomials. All right, let's do another. Okay, our next example, we want to factor completely 4x cubed plus 108. Okay, so some pretty big numbers here. Triple digit, 108. But 108 divided by 4 is 27. So the GCF is 4. We can factor out a 4 here, leaving you with just x cubed plus 27. Okay. Now, can we go any further? X cubed plus 27. Well, I hope you recognize by now that 27 is a perfect cube. It's 3 times 3 times 3, which is 3 to the 3rd power. Okay. So we have x cubed plus 3 cubed. So that to me looks like the sum of 2 cubes, right? A cubed plus b cubed. And I might need a little more space here, so let me write that down here. A cubed plus b cubed, right? So here a is just x, and b is just 3. So this should factor as a plus b times a squared minus ab plus b squared. All right. So that should do it. Don't forget the 4, the GCF. But then we have a plus b, which is just x plus 3. And then a squared is just x squared. Minus a times b. A times b is x times 3. But that looks backwards, right? The 3 goes in front, so 3 times x. Plus b squared is 3 squared. 3 squared is 9. Okay? And remember, even though this is a trinomial, don't bother trying to factor it. It's going to be prime. Right? This trinomial here will always be prime. So the good news is that we're done, right? We don't have to go any further. So that's the answer. Right. The bad news is that you do have to remember the sum of cubes. As unpleasant as that is, you have to know it. There's no other way to do it, as far as I know. Right. So again, if you leave it like this, you're only going to get partial credit because it's only right. It's only factored partially. You did factor out the GCF, the 4, which is good, but you have to keep going. Right. Yeah. I mean, look. The other way that you could do this is to divide. x cubed plus 27 by x plus 3, which you did way back on your previous test, right? Way back in chapter 5. You would do the long division, right? And remember, there are missing terms here. There's 0x squared plus 0x plus 27. So, yep, as long as you recognize that this factor here is x plus 3, you can get the other factor by doing the division here. Right? So you end up with what? X squared, and then, x cubed plus 3x squared. When you subtract, you get negative 3x squared plus 0x plus 27. So now when you divide negative 3x squared by x, you just get negative 3x. And when you multiply by x, you get negative 3x squared, and then negative 9x. Switch the signs and add. And finally, negative 9x by x divided by x is just 9. And when you multiply, you get 9x squared plus 27, or switch the signs, and when you add, you'd get a remainder of 0. So that means it divides evenly. And as you can see, that is the other factor, up here. All right, so this is a good review of, right, I believe it's section 5.7. This is just long division. However, if it's all the same to you, I just prefer this. As long as you know this, that gets you the answer without having to go through all this dreadful division here. So again, ideally, you should know the sum and difference of perfect cubes as well. Right. Otherwise, it's just a lot more work. Okay, so yep, that's a binomial where after you factor out the GCF, you get the sum of cubes. Oh, I guess that's it. All right, let's do a few more. Okay, factor completely 2n squared minus 40n plus 150. Okay, so GCF is 2 because they're all even numbers, and the smallest factor is 2. So again, factor out the 2, leaving you with n squared minus 20n plus 75. Okay. Well, the next step is to see if we can factor this trinomial. Again, 3 terms, trinomial. And since a is 1, let's just use the shortcut. Can we find 2 numbers whose product is 75? And when we add them, the sum should be negative 20. Well, 75 is negative 1 times negative 75, but that adds to negative 76, not negative 20. So, can we divide by negative 2? Nope. Can we divide by negative 3? Sure, we get negative 3 times negative 25 is 75. But when you add negative 3 plus negative 25, you get negative 28, not negative 20. So that's not it. Can we divide by negative 4? Not evenly. Can we divide by negative 5? Yes, negative 5 times negative 15 is 75. And negative 5 plus negative 15 is negative 20. And there's our match. So that tells me the 2 numbers here are negative 5 and negative 15. And so we're done. Okay. All right. Let's do another. Okay, next one is factor completely 5r to the 4th minus 45r squared. Okay, so GCF is 5r squared. So factor out the 5r squared, leaving you with r squared minus 9. Okay. Now, what about r squared minus 9? Can we do anything with that? I hope you recognize that the 9 is 3 times 3. It's a perfect square. So this is nothing more than a squared minus b squared, where a is r and b is 3. And when you factor a squared minus b squared, you just get a minus b times a plus b, or in this case, r minus 3 times r plus 3. So don't forget the 5r squared, that's the GCF, times r minus 3 times r plus 3. And now we're done. Okay. So it just takes getting used to. Let's do one more. Okay, so I think I saved the hardest one for last. Factor completely x to the 4th plus 4x cubed minus 16x squared minus 64x. Okay, step by step, right? First thing is, what's the GCF? It's not 1 because every term, all 4 of these, contain a factor of x. So that tells me we can factor out an x. So when you divide, essentially you're just decreasing all the exponents by 1. Instead of x to the 4, it's now x to the 3. X cubed becomes x squared becomes x. And then when you divide negative 64x by x, you just get the negative 64. Got it? So that's the GCF. Right. Now what do we do? So now we have 4 terms. So 4 terms means grouping. So we're going to be factoring by grouping. And that just means, well, here, let me rewrite it. Okay, so just to make this clear, we're going to factor the first 2 terms and the last 2 terms separately. So from the first 2 terms, we can factor out an x squared, leaving us with x plus 4. From the last 2 terms, we can factor out a negative 16, leaving you with x plus 4. Okay, so this should work because we have a common factor of x plus 4. So let's factor that out. And what does the x plus 4 multiply? It multiplies x squared minus 16. So we multiply by x squared minus 16. Okay, now what? Well, x squared minus 16 looks familiar, right? It's the difference of 2 squares. 16 is 4 times 4. So this here, again, is just a squared minus b squared. Let me move that down a little. Right, which is just a minus b times a plus b. Again, in this case, right, a is x and b is 4. So, yep, we should be able to factor, let's see if I can erase this. Looks like we're dividing. Yep, we should be able to factor this as x minus 4 times x plus 4. Right? That's just a minus b times a plus b. Right. And even though 4 is a perfect square, right, it's not x squared minus 4. So it's not the difference of 2 perfect squares here. Although, yep, if this were x squared, you could go further, right? You could do x plus 2 times x minus 2. Not in this case. So that should be it. Now there's one crucial thing here. X plus 4 times x plus 4 is really x plus 4 squared. So I think we leave the x in front, and then we'll do the x minus 4, because then x plus 4 times x plus 4 is really x plus 4 squared. And now we're done. So yeah, this one was a bit of a long one. There's a lot of steps here. There's the GCF, there's the grouping, and then here there's the difference of squares, difference of perfect squares. So three problems all in one. And in the end, you're just going to end up with x times x minus 4 times x plus 4 squared. All right, so I hope this helps. Right, so by now you should all be experts at factoring. And we're going to need this, right? In the next section, in the next video, we are going to be factoring a lot more. So this hopefully gives you enough practice where you should be able to do any factoring problem that comes up in the homework. So best of luck.